So today our goal is to find a general antiderivative. Over the past couple days, we've been looking at finding specific antiderivatives, which means we've been finding areas under a curve from a beginning endpoint to an ending endpoint. And that area was a set bound. Today, we're going to find areas that are not such set bounds. So we're going to find areas of curves that are general. So for example, in the warm-up, I tell you to think about the function f of x equals 3x squared. Its antiderivative is x cubed. However, there's this idea that it's actually the family of x cubed because the derivative of a constant is 0. So what that means is that technically the derivative is x cubed. Technically, it could be x cubed minus 1. Technically, it could be x cubed plus 2. Technically, it could be x cubed plus 212. So this function has this derivative that's 3x squared, but its antiderivative is the family of x cubed that can live above the axis, below the axis. It can be shifted up or down all over the place. So that's kind of where we're going with today. It turns out that there are many antiderivatives to the following function. So capital F of x could be x cubed plus 1. It could be x cubed minus 3. The list goes on and on and on and on. So what we do in calc is we give it this general plus c that stands for any constant in the world. So the antiderivative becomes f of x equals x cubed plus c. So instead of saying what function would have a derivative of f of x, we could write the integral from f of x dx. And what you'll notice is that there are no bounds on this integral. It's boundless. If there are no upper and lower limits, then we know our integral is a general integral, and we're going to have a plus c. So we talked about indefinite versus definite. This is known as an indefinite integral. So capital F of x is known as the antiderivative of lowercase f of x. On an interval I, the most general antiderivative is called capital F of x plus c. So you'll hear it called a general antiderivative, or you're going to hear it called an indefinite integral. So it's either going to be a general antiderivative or an indefinite integral. How do we find an antiderivative using the power rule in reverse? Well, what we do is we take x to the n, and we add 1 to our power and divide by the new power. So the antiderivative is our reverse power rule that we've been talking about. That does not change. So again, this is just me reiterating the reverse power rule that we have already previously talked about. But now we're going to talk about it in general. So how it changes is that now our reverse power rule will have a constant at the end. Go away, cute. So we have these basic rules of integration. We've talked about all of these previously. So these rules are going to allow us to basically find a whole bunch of general antiderivatives. So what you'll notice is now each of these rules has the plus c tacked on that wasn't previously there. So all of these rules have a plus c tacked on that was not previously there. Okay, so here's where I'm going to switch over because I don't have my ability to use the iPad. So we're going to switch over. Hopefully this goes to good. My document camera. We're going to spotlight that for everyone. And I'm just going to do these on paper with you. Okay. So if f of x equals 12x squared plus 6x minus 4, our general antiderivative is quite the same. You're going to open it up. You're going to look at the power rule in reverse, and you are going to simply tag on a plus c at the end. So we're just going to add on a plus c at the end. So the antiderivative would look like this. And then your reverse power rule would say 12x cubed over 3 plus 6x squared over 2 minus 4x plus c. And then you would simply just clean up. 12 divided by 3 is 4x cubed. 6 divided by 2 is 3x squared minus 4x plus c. In this example, in letter B, what I would do is I would take the denominator and rewrite it under each of my numerators. So I had x over x to the 1/2 plus 1 over x to the 1/2. And then I would simplify that again. So x over x to the 1/2 becomes x to the 1/2 plus x to the negative 1/2. And essentially what that does is that allows you to take the reverse power rule without a fraction. So now the antiderivative of x to the 1/2 plus x to the negative 1/2, and we always tag on our dx, and I should have done that up there, is equal to x to the 1/2 plus 1. So if you think about 1/2 plus 1, that is 3/2. Because we're going to have to flip our fractions. We can't have these gross fractions and fractions. So we have our fraction, and then what we're going to do is do that again. So you have x to the negative 1/2 plus 1 over negative 1/2 plus 1, which is a half, plus our general c. And then we're going to multiply by the reciprocals. So my fraction becomes 2/3 x to the 3/2 plus 2 x to the 1/2 plus c. And that is my general antiderivative. I can leave it just like that. In letter C, we don't have a rule. This would be like a chain rule. We don't have a rule for that. So the only way you can do letter C is to FOIL it out. So you have to take t squared plus 1 and FOIL it. So you get t to the 4th plus 2t squared plus 1. And so what we're going to do is take that value, and we are going to now take its antiderivative. So go ahead and do that for me real quick on your own, and I will touch back with you in a few minutes and see how we do. So I'd like you to actually try like the next t squared values. We got capital F of x is equal to a 1/5 t to the 5th plus 2/3 t cubed plus t plus c. So the big important part is not forgetting that that plus c now exists, because that plus c is going to allow you to find the general. So now we want to look at the one involving the trig function. So you want to think of the trig function as being factored out in front. So we really want to think of that as like 2 the integral of sine x dx. So then what we have is that capital F of x, or our antiderivative, is equal to 2. The antiderivative of sine is negative cosine plus c, or we get negative 2 cosine x plus c. In letter E, we want to think of that as the trig function sort of broken out. So you have sine x over cosine x times 1 over cosine x. So that could transform into tan x secant x. And now if you go back to your table, tan x and secant x are one of our rules. So the antiderivative of tan x secant x is secant x plus c. So capital F of x is equal to secant x plus c. In letter F, that's the other one I told you could give it a try. So hopefully you did what we did in letter B, and you took your denominator and you broke it out into each part. So that would have been 2600 x to the negative 3. And then after that, you would have wanted to take in the next part and do x over x cubed. So you get 2x to the negative 2. Plus 0.001 x to the negative 1. And then at that point, you're just going to take your antiderivative by adding 1 back to each of your exponents. So negative 3 plus 1 becomes negative 2. So capital F of x is equal to 2600 x to the negative 2 over negative 2 plus 2x to the negative 1 over negative 1 plus 0.001 x. Well, negative 1 plus 1 becomes x to the 0, and we know anything to the 0 power is 1. But then what does that do to your denominator? That gives us an 0, and that should hopefully spark our reminder that x to the negative 1 is really 0.001 over x, which is really 0.001 and like 1 over x, and we know that that can be factored out in front, and my 1 over x becomes an ln. So this isn't really the x to the 0, this is our fancy dancy little ln of x. So again, if you make the mistake, what's really nice is you end up getting that 0 in your denominator, and it helps you see, oh, it's an ln, like I forgot. And then don't forget r plus c, and we just want to clean everything up after that algebraically. So we have 2600 divided by -2, so that's -1300 over x squared, -2 over x, and then plus, and you could rewrite 0.001 as a fraction if you wanted. It's 1 over 1,000 ln x plus c.
Ms. McBride?
Yes.
Will it always be ln absolute value x?
Yes.
Okay.
So it's kind of like the ln absolute value is kind of like, if you think back to in the algebra days, is the back of this packet blank? No. If you think back to the algebra days, if you take the square root of x squared, that's equal to the absolute value of x, because anything squared has to be positive, and you can't take the square root of something negative. But if you simplify this and you just write x, we don't know without the absolute values that that x has to always take on a positive value. So similarly with the ln's, you can't take the ln of a negative. So those absolute values come into play because the domain of a natural log is the positives. Does that help kind of clarify or make the connection a little bit?
Yep, that makes a lot of sense. Thank you.
You're welcome. So then f of x in this case is kind of just a continuation of what we did with letter f. Antiderivative of 1 over x is the natural log of x plus c, where once again you have those absolute values around your natural log of x. I feel like that's on the rules on the previous page too, or the ln's aren't on that rule page. Okay, so then we're going to go back. I told you we're kind of playing a little game here with my slides and the document camera. So we're going to go back to the document camera, and I'm going to give you 3 of our definitions. So I have e to the x, natural log of x, and a to the x. Okay, so those are our general rules. So what we're going to do now is apply them. So in that example below, we look at our first antiderivative of an e to the x. So e to the x is nice in all forms because e to the x is always e to the x. Where it changes or takes on new properties is when that x changes from just a general x. And we are going to get into that in chapter 6 with what we call u substitution. So for now, e to the x and a to the x are going to stay very simple. They're going to just stay within our rules. But as we move into future problems and things get a little bit more challenging, they are going to change. But for now, it's constant e to the x plus c. The whole reason we do the plus c and we talk about this family is because we can actually solve for c. So the c actually has a value if we know something called initial conditions. So we can solve for c using initial conditions. So I'm going to go back to my document camera with you, and we're going to do this initial condition problem kind of together, walking through exactly how to find that function. So we have f prime of x equals x square root x. So I would probably transform my f prime of x so that I didn't have a square root and a function being multiplied together. I would rewrite that as a single rational exponent. So what that really means is f prime of x is equal to x times x to the 1/2. But a rule of thumb is that if you have like bases, you can add their exponents. So it's really like an exponent of 1 and an exponent of 1/2. So this is really like saying f prime of x equals x to the 3/2. So now when you find your antiderivative of that, you just have to do your power rule, which says you add 1, and then we multiply by the reciprocal when we get a fraction in our denominator. So it'd be like x to the 5/2 over 5/2, but you just multiply by your reciprocal when you have a fraction in the denominator, so that would give you 2/5 x to the 5/2 plus c. And that plus c is really important because we are going to now take the idea that this represents f of x, and we can find our c value for f of x. So we're going to plug in our initial conditions, which says when x is 1, y is 2. So what that means is we have 2 equals 2/5, 1 to the 5/2 plus c. And then we're going to solve for c. So we have 2 equals 2/5 plus c. So we subtract 2/5 from both sides, and we get 1 3/5, or you could say 8/5 is equal to c. So what that means is my f of x with that initial condition is equal to 2/5 x to the 5/2 plus 8/5. That is my function that applies the given initial condition. So that's the function that applies the initial condition given. So this represents the general family function. This represents the function given that initial condition. So let's do one more where we have an initial condition and a function sort of in general. Now this time we have an initial condition for f prime, or f, and our given is not f prime, but f double prime. So what that means is I actually have to go about finding my antiderivative twice. So I actually have to go about finding my antiderivative twice. So we're going to find f prime of x, which is 12x cubed over 3 plus 6x squared over 2 minus 4x plus c. And then we're going to go ahead and find f of x. So that became a 4 on that property because 12 divided by 3 is 4. 6 divided by 2 is 3. So we get 4x to the 4th over 4 plus 3x cubed over 3 minus 4x squared over 2 plus, we're going to call this C1 x plus C2. So a constant on f prime would get an x on f, and then we have to now have a second constant because we antiderive twice, so we have two constants. Eventually we're going to be able to find out what the value of C1 and C2 is. And we can do that because we're given two initial conditions. And one of those initial conditions has a 0. So what that means is it's going to zero out all of my variables. So when x is 0, we have 4 equals 0 plus 0 minus 0 plus 0 plus C2. So C2 is 4. Now we can plug in C2 to find C1. So f of x is x to the 4th plus x cubed minus 2x squared plus C1x plus 4. So now we're going to use the initial condition 1, 1 to find C1. So we have 1 plus 1 minus 2 plus C1, 1 plus 4 equals 1. So 1 plus 1 is 2, but 2 minus 2 is 0. So then we have C1 plus 4, so we're going to subtract 4. So we get negative 3 equals C1. So C is negative 3, which means my f of x is x4 plus x cubed minus 2x squared minus 3x plus 4. Okay, so let's go down and talk about the ball being thrown. So we have one more problem. So we have a ball is thrown downward from a building such that its downward velocity at 1 is 76 feet per second. So we know that v of 1 is 76 feet per second. So I just like to write down what I know. And if it's being thrown downward, then we know the velocity in the downward direction is negative. And we're given it is 10 feet above the ground. So that's my position. So that's S of 2 equals 10 feet. Now, not given, but something that I guess textbooks kind of consider to be understood is that in terms of feet per second, acceleration is a constant due to gravity. So what that means is that in terms of this problem, we are taking into the idea that the acceleration due to gravity is always negative 32 feet per second squared. And that's what we call acceleration due to gravity. So we have to use that to find velocity, and then use velocity to find position. So let's go ahead and do that now. So we'd get the velocity as negative 32t plus c. And then we could use that negative 76 to go about finding my c. And that c value we found is going to represent the initial velocity. So the initial is negative 44. So it says, what is the ball's initial velocity? Well, the initial velocity is 44 feet per second in the downward direction. So our equation would be v of t equals negative 32t minus 44. How tall is the building? Well, to determine how tall the building is, you would have to take the antiderivative of velocity. So you get s of t is negative 32t squared over 2 minus 44t plus c. So that gives negative 16t squared minus 44t plus c. And then we're going to go plug in that initial condition of 210. So we get negative 64, negative 88 plus c. And then what we're going to do is combine like terms and then move that over to the other side. So negative 64, negative 88 plus 10 would give me a c value of 162. And again, that 162 would be the height of the building at which the object is thrown, because that's like your y-intercept. So my s of t is negative 16t squared minus 44t plus 162, where 162 represents the height of the building where the ball is thrown. questions on any of that? So on the next page, I gave you a couple examples of antiderivatives. So I'm going to have you do that next page for homework, numbers 1 through 8. And then we will pick up tomorrow with the second part of this, which is going to be the fundamental theorem of calculus. So we'll pick up tomorrow with part 2. So your homework for today is just to do 1 through 8 on that next page, and I will go create a Dropbox for you for that now.